All right, so right now we're going to go ahead and look at adding polynomials. Adding polynomials is one of the easiest things that we're going to be doing, is because we already really know how to add polynomials. All right, and let's look at this really quick here. So if I had a monomial and I add it to another monomial that happens to be a like term, all I do is add the coefficients, so 3 plus 2 is 5, and I keep the x. And I have added two polynomials that happen to be monomials. Right? And the same idea is going to go for adding polynomials no matter how you see them. All right? So if I have something like 3x plus 5 plus x plus minus 7, all right? All I'm going to do here is combine like terms. So my 3x and my x are like terms. They both have an x. They both have an exponent of 1. And that will give me 4x. And then my 5 and my minus 7 I can combine together. And 5 minus 7, negative 2. And at this point, I'm done. I've added polynomials, and this is the result I get. Instead of writing them like this, like when we're just combining like terms and expressions, we're going to write it slightly different, but it's not any different as far as procedure goes. All right. So if I were to go ahead and take the same problem, and I'm going to say, okay, I have 3x plus 5, and I'm going to add it to x minus 7. Even though these are in parentheses, this plus sign here doesn't change anything. And all I'm going to go ahead and do is combine like terms. So I have 3x and x, which still gives me 4x, and plus 5 and minus 7 still gives me the negative 2. So even though this problem looks different, it is exactly the same thing. So everything we're going to see as far as adding polynomials is going to look more like this and not like this, but it doesn't mean that they're any different. Let's go ahead and look at a few examples. All right. So here I have two polynomials. I have two trinomials. And the only thing I'm going to do is combine like terms. Now, something I like to do when I get a hold of something like this is I like to go ahead and take this second piece and write the like terms under each other if I can. All right. So I'm going to write my x squared term under my x squared term, and we all know that there's a 1 in front, if I care to write that. My x term goes under my x, and my number goes under my number. And it is a lot easier to go ahead and combine the numbers when they're in this vertical idea rather than horizontal. All right? So we're going to go ahead and add them together. So 3x squared plus 1x squared is 4x squared. 3x plus 2x is going to give me 5x. And 2 plus 13 is going to give me a positive 15. So at the end here, I've gone ahead and added them, and I just write them under each other, and it makes my life just a little bit easier. All right, let's go ahead and look at another one. So again, I'm going to do the same thing. It doesn't matter which one you write under each other because of the plus. So I'm going to go ahead, in this case, take the first one and write them under the second terms, the second polynomial, it doesn't matter. So my x squared is going to be written under my x squared term. My 4x is going to be written under my x term, and my minus 7 under my number. Right? And I'm just going to go ahead and add them together. So a negative 4 plus 1 is going to be a negative 3x squared. Negative 2x and a negative 4x. I spend $2, I spend $4. I spent $6, but I spend 6x's in this case. A plus 1 and a minus 7 gives me a negative 6. And I've gone ahead and completed my problem. Right? What if everything is not the same? All right, let's go ahead and look at this. Now here I have a binomial. I'm adding it to a trinomial. And I want to go ahead and write my like terms under each other. And so I'm going to take my binomial and write it underneath my trinomial. All right, so I have an x squared term. I'm going to go ahead and write it underneath. I could put the 1 if I would like. And I have a plus x or plus 1x. And then I'm going to go ahead and add these together. All right. So I have a 2x squared and a 1x squared. I'm adding them together. I get 3x squared. I have a minus 3x and a plus 1x, which gives me a minus 2x. Now notice there's nothing here underneath my number. All right. We are just assuming that that's a 0. We're adding 0. And when you add 0, it doesn't change anything. So this basically drops down and becomes a plus 14. All right. So it's really important to go ahead and fill in those holes. Only write underneath whatever you have a match for. Okay. And we're going to go ahead and look at this one too. This one looks a lot more complicated, but it's really not. What we're looking for is the like terms. All right. And so I have an AB squared. What I want to look for in the second one is, do I have an AB squared? I do. It's right here. So my 3AB squared is going to get written underneath. Do I have a B? Yes, I have a 2B. So that 2B gets written underneath the B term. And I have a A squared that I'm going to write under the A squared term. And I'm just going to go ahead and add those together. Remember, in front of all these is an invisible 1. So we need to take that in consideration. I have 1 plus 3, which is 4. And you just write the variables as they are. Don't try to do anything with them. I have 1 plus 2, which is plus 3b. And I have 1a squared plus 1a squared, which is plus 2a squared. So all you're really looking for is make sure all your variables and all your exponents are exactly the same so that you can match them up. One more for you here, all right? So here I want to go ahead and match everybody together, all right? And I have an x squared plus xy plus y squared. And then I have a plus 2x squared, so I have a match. I'm going to write that 2x squared underneath my x squared term. I have a plus 3xy. Which I'm going to write under my xy term. And then I have a plus y. This has no match with anything in the first one. So what I like to do, he's going to kind of go out here by himself. And for the y squared, because I don't have a match, I put 0y squared. And I'm simply doing that as a placeholder just so I don't accidentally go ahead and try to add this term to this term because they're not the same. I'm going to go ahead and add them together. So x squared plus 2x squared is 3x squared. 1xy, because we know there's a visible 1, plus 3xy is plus 4xy. Now my y squared did not have a match, so my y squared basically just drops right down. And my y didn't have a match, so I just have a plus y. All right, and I know we've been talking about descending order, but when you have more than one variable, it's really hard to go ahead and put it in that descending order type of thing. So leaving it like this is totally okay. All right, you could totally do this. Leave it as it is. Don't try to rearrange it. Just leave it and move on to the next problem. Okay, go ahead and work on the practice, and I'll see you in the next video.